All right, hey guys, Algebra 1, welcome to another video of notes. All right, we are in section 3 today, chapter 4, section 3, talking about multi-step inequalities. All right, so let's jump right into it. Very important, you can see it on the screen. The steps are still the same. Things did not change just because inequalities were thrown at you. All right, so I don't want you to get overwhelmed or confused or somehow messed up just because I took away an equal sign and replaced it with an inequality. All right. So up to this point, the steps don't change. The only thing that, yes, you have to remember, which we've done in a prior section, is that if you multiply or divide by a negative coefficient, then that will flip the inequality. Okay. So all the other steps are still the same when you're solving a multi-step equation. Now that it's an inequality, the key piece to remember is if you multiply or divide by a negative coefficient. Remember, that's the number in front of the variable. If that is a negative, then your inequality sign will flip. Okay? Okay. All right, a key thing to remember as well, of course, get all the variables on the same side, get all the constant values on the other side, but that just goes down to doing it the same way. All right, it doesn't change. All right, let's jump into some example problems here. We're going to do some graphing on some of these just so that you can, again, still see all about the shading or filling in. Do we fill in the circle? Do we leave it open? All right, let's take a look here. Okay, so the first one that we have up, we have a negative 6x plus 5 less than or equal to negative 3x minus 16. Okay, another thing to remember is we always want the order to be the variable, then the inequality sign, and then the final number. Okay, that's the proper order. All right, so let's go ahead and take that negative 3x. Let's move it to this side. We're going to take the 5 and move it to that side. Let's rewrite a negative 6x now plus 3x less than or equal to a now negative 5 minus 16. Okay, so when you move things across an equal sign or across an inequality sign for that matter, the sign on the number will change. All right, so don't forget that. Okay, so these guys with the x values, we are going to have a negative 3x less than or equal now to a negative 21. Okay, and then we are almost done here. So let's now divide both sides by that negative 3. So that will then isolate the variable. So these guys will cross out. We now have x isolated, and a negative 21 divided by a negative 3 will create a positive 7. But notice that right there was a negative coefficient, meaning that I will have to flip the inequality sign. All right, so I'm going to circle both of those pieces because a negative coefficient flips the inequality sign, and now we have our final answer, x greater than or equal to a positive 7. Okay, all right, let's take a look now at example 2. Again, graph. We're going to solve it first, though. Oh, you know what? I didn't graph this one. Sorry about that. Let's go back up real quick here. So if we want to graph it, let's see, we can fit a number line in right there. All right, don't forget, let's put 0. Let's put our arrows. All right, and just for the sake of time, we'll say that right about there is as far as 7 would go. We have a circle. It does say or equal to, so we have to fill in our circle. Okay, and then it is greater, so that's going to go that way, right there. Okay, so there's our number line. There's a filled in. Go to the right. There we go. Looks good. Okay, let's take a look now at our second example problem. All right, so we have a negative fraction. Let's try to get rid of that fraction. How could we get rid of this and basically not have a fraction at all? We could multiply by its denominator. All right. If we multiply both sides, let's say we're going to multiply all of this and we're going to multiply this by the denominator. That would be multiplying it by a -4 and multiply this by a -4. That will then eliminate the fraction. Basically what it's doing is it is actually just leaving behind the numerator, the top number. But in our fraction, we like that because the numerator is 1. So it's kind of like it's eliminating the whole fraction. All right. So if we multiply a -1/4 by a -4, they will fully, by the way, if I wanted to, we could show you with the 1 on it, they will fully cross everything out. So on the left-hand side, that fraction is gone now. And then on the right-hand side, we do need to multiply that -4 by -2, giving us now a +8. And then let's rewrite what we have left. All we have left now is that. That really simplified it down. So multiplying it by that -4, why did we do that? Because that was the denominator of the fraction. You can always multiply a full expression by its denominator, and that will just leave behind the numerator. In this case, the numerator being 1, really nice. Basically looks like it eliminates that whole fraction. Okay. All right. So now, simple enough, we're just left with a +12 to both sides. These guys cross out. You have x greater than 20. Boom. That was simple enough. So that key first step just really set the tone. Multiply by that denominator, everything simplified very, very nicely. Okay, and again, if we wanted to do this on a number line, real simple here. Okay, let's see, change the color. Make sure you put your 0, you got your arrows. Again, saving time. Let's go and say, hey, that's pretty far down the line. There's 20. Open circle, leave it open because it just says greater than. All right, and then go to the right. That's the greater than side. Move to the right. Okay, good, good. That is our second example problem. Let's do our third one here. All right, now something real important. This is where you should have kind of that red flag goes up or that bell goes off in your head. You should notice that on both sides of the inequality, what do you have? All right, I'm hoping that everybody's saying you have a 3x on both sides, meaning identical coefficient, identical variable, a 3x on both sides. If that's your case, right off the bat, they will cross each other out. All right, because if you have a 3x and you move a 3x over, then it will say 3x minus 3x. That's 0. So if you know that right up front, that drops out, then here's what you're left with. You're left with a -12 is less than or equal to a -4. All right. Now, this is a little different than an equal sign. You'll remember, if we were looking at this as an equal sign, it'd say -12 is equal to -4. Clearly, no, it's not. And boom, you just say no solution and you move on. But inequalities are a little different. You have to look at the expression and ask yourself, is this actually a true statement? Because inequalities are not just equals. They do involve a lot of other numbers down a number line. Okay, so if you take a look at this problem, is -12 less than or equal to -4? Yes, it is. It is less than -4. So this would actually be a yes, all numbers. Okay, inequality signs are very important because they make statements that actually could be true even if the numbers are not the same. Because up to this point, all you've dealt with is equal signs, and equal signs tend to be very cut and dry. Inequality signs are not quite that way. Okay, so let's move on to number 4. Last example problem that we will be doing. First step, you see a number on the outside of parentheses, you distribute. For starters, it's not a fraction, so we don't have to worry about that. We can jump right into distributing this number. 5x plus 25 less than 5x minus 17. Okay, now again, you should have that bell going off in your head. I see a 5x on one side. I see a 5x on the opposite side. Both same coefficient, same variable. So that means these guys right here, identical, opposite sides, will cross each other out. All right? They will cross each other out. Totally gone, leaving behind the statement 25 is less than a negative 17. Now you have to look at it closely because it's an inequality. Is 25 less than negative 17? Nope, it is not. So this would be a no solution. Okay? Because it is not a true statement. No solution. All right. That covers the notes for today, guys. Yep, last example problem. Make sure, again, you're watching this, you're copying all the notes down and all the example problems down. Do all of that, and you guys are going to be just fine. All right? See you in the next video.